All right, today we're going to talk about multiplication and division inequalities. So let's just take a look at the steps for solving these. Step number one, as always, is to write it down. So step number one is to write the inequality down. Step number two will be to show the inverse operations on both sides of the inequality. Step number three is going to be to multiply or divide to solve. Notice we have some asterisks out here, so there must be something important to remember. And step number four is to graph the solution set. Let's take a look at what this important note we need to remember is. It says, if you multiply or divide by a negative, you must flip the direction of the inequality sign. Okay? This is only if you multiply or divide by a negative. So let's take a look at a few examples and see how this works. In this first example, 3x is less than or equal to 27. They're multiplying x by 3, so the inverse of that would be to divide both sides by 3. We're dividing by a positive 3, so there's no need to switch the inequality sign. So we just go ahead and finish it. 3 divided by 3 is 1. 1 times x is x. 27 divided by 3 is 9. So we end up with x is less than or equal to 9. Now, if we remember how to graph them, since this says or equal to, 9 is part of our solution set. So we're going to start out by numbering our number line. We'll put 9 in the middle. Since 9 is part of the solution set, we're going to put a solid dot and we're going to shade it towards the less than direction. So we can check it by plugging in, remember. We can take a number from the shaded area and plug it in and see if it makes a true statement. 8 is less than or equal to 9. Is that a true statement? Absolutely. So let's move on. Our next example is 5x is greater than or equal to negative 65. Well, they're multiplying x by 5, so the inverse of that is to divide by 5. When we divide by 5, the 5's cancel out, leaves us with x. Over here we have negative 65 divided by positive 5, which would be negative 13. There again, there's no need to switch our inequality because the number we're dividing by is positive. So we're going to end up with x is greater than or equal to negative 13. So we'll put our numbers on our number line so we can get a snapshot of that number line. Our starting point is negative 13 and it is part of the solution, so we're going to put a solid dot there and we're going to shade it towards the greater than side. Okay, we can check it, plug in negative 12. Is negative 12 greater than or equal to negative 13? Yes, it is. One more multiplication example. This time it says negative 5x is less than 25. Since we're multiplying x by negative 5, the inverse would be to divide by negative 5. Now remember, this is when we're going to switch the sign because our inverse operation is divide by a negative. So negative 5 divided by negative 5 cancels out. We're left with x. Over here we have 25 divided by negative 5, which is negative 5. We have to switch the direction of the sign, so we're going to end up with x is greater than negative 5. So let's go ahead and put our numbers on our number line. This time, since it does not have the or equal to part, negative 5 is not part of our solution. So instead of a solid dot, we're going to use an open circle. We're still going to shade it towards the greater than side. So it'd be open circle on negative 5 and shaded to the right. Now if we want to make sure we shaded it in the correct direction, take one of the numbers from the shaded side, which in this case be negative 4, plug it in for x. Negative 4 is greater than negative 5. Is that a true statement? Absolutely. Let's take a look at how it works with division. So this says x divided by 4 is less than 11. The inverse of dividing by 4 is to multiply by 4. So we're going to multiply both sides of this inequality by 4. Over here, the 4's will cancel out. It leaves us with x is less than 11 times 4 is 44. Our inverse operation, we're multiplying by a positive 4, so we will not change the direction of the sign. And we end up with x is less than 44. We'll go ahead and plug our numbers into our number line just to give us a snapshot of that number line. And since we have is less than, okay, not the equal to part, we're going to put an open circle on 44 and shade it towards the less than direction. We can always check it. We plug it in. Is 43 less than 44? Yes, it is. Let's take a look at this one. There's a negative number in it. Let's see if we need to switch the sign. They're dividing x by 7. The inverse of dividing by 7 is to multiply by 7. Since our inverse operation involves us multiplying by a positive 7, there's no need to change the direction of our inequality sign. These 7's cancel out, leave us with x. Negative 8 times 7 is negative 56. So our solution to this inequality is x is less than or equal to negative 56. We'll go ahead and number our number line so we can get that snapshot. This time it does include the or equal to part, so we're going to use a solid dot on negative 56. We're going to shade it to the left or to the left than area. One more. On this one, we have two negatives in it. Let's see what happens. We have x divided by negative 2 is less than negative 13. The inverse of dividing by negative 2 is to multiply by negative 2. When we do so, this is going to cancel out, leave it with x. Negative 13 times negative 2 is a positive 26. Our inverse operation involved a negative. We are multiplying by negative 2. That tells me I have to switch the direction of my inequality sign. So our solution to this one is going to be x is greater than 26. We'll number our number line, and then this one does not include the or equal to. That tells me it's going to be an open circle, and then I'm going to shade it to the right, which is the greater than direction, and this is the solution set to our inequality. I hope this helps. Be sure to reach out if you have any questions. Have a good one.